In this lesson, the first thing we're going to look at is the idea of reflection. And in this first problem, we're talking about reflection across the y-axis. And our y-axis is our up and down axes. So all we're going to do is take every single point, x, b, and j, and reflect it as if we're folding the paper right along the y-axis. So since my x point is 4 spots to the left of y, my new x point will be 4 spots to the right. Since j is 3 spots away, and with b being 5 spots away. Notice, because we're going across the y-axis, we didn't move this up or down, we just reflected it across. Now if I were to take these lines and connect them, that triangle is a reflection of the original triangle across the y-axis. Notice this is what we call reverse orientation, meaning everything is exactly backwards. In problem 3, they're talking about going across the x-axis. We follow the same idea, except your x-axis is the horizontal axis. Well, let's look at point x first. It's 3 spots below. So the new spot I put is 3 spots above. Do the same thing with e. Since m is on the axis, reflecting it is going to put it right back where it started. And my new triangle is still congruent to my old triangle. Keep that in mind, we're talking about congruent triangles. The triangle's shapes have not changed. The only difference is it has reverse orientation. What if we have the same idea, except instead of giving us the picture to reflect, they give us the ordered pairs? Well, keep in mind, when we talk about an ordered pair, the first letter, the first number, the 2, represents the x value, and the -5 represents the y value. So for me to go from v to -5, I'm going to go 2 spots to the right of the origin. Don't forget the origin's right where the two axes come together. And I'm going to go 5 spots down. I'm going to put a point right here. And I'm going to call that v. Point T, 3, 0. And point J, 5, -1. And now I have my triangle. Once I have my triangle, I'm reflecting across the y-axis. I go ahead and I do the exact same thing I did before. 3 spots to the left, J's 5 spots to the left, and V. And again, I have the exact same idea, except I have what we call reverse orientation. And you could do that with a problem like this down here in number 7 without actually ever worrying about drawing the picture. Well, look at my picture up here in number 5. My t and my t prime, my reflection, when we were across the y-axis, the x value became the opposite. My t value was 3, 0. My t prime is -3, 0. Look at my original v. 2, -5 to -2, -5. So whichever axis you're talking about, that letter, that number is going to stay the same. But we're going to end up with the opposite. And if you'd like to, go ahead and graph this and check it. Now we're going to talk about rotation. And rotation is a little bit hard to wrap our minds around here. Think of a rotation, think of a Ferris wheel, think of a merry-go-round, or think about the Earth going around the sun. When we talk about rotation here, we're actually going to take these points and we're going to go counterclockwise around the origin. We're going to put a point right there at the origin. We don't need that point, that's just a guide point for us. And basically what we're going to do is, imagine that there's a line that connects the origin to W. Well, it's kind of weird to think, but I came down 3 and over 1. If I reverse that idea, it's going to give me a right angle. And this is going to be my new W point. Now remember, these two lines that I drew in here, they're just imaginary lines. They're just visual for us. And look what happens in my order pair. If I talk about W, my W goes from -1, 3, and my new W ends up being -3, -1. If we're talking about a rotation of 90 or 270 degrees, your X and your Y are going to flip-flop spots. The absolute value of the number, so the number itself. Once you know that the number is going to change, so again, let's look at a number like R. If you look at point R has an order pair of -3, 2. Well, I'm going 90 degrees. So I know that my new R value is going to have a 2 in the front spot and a 3 in the back spot. I just don't know which one's positive, which one's negative, or if they both are. Well, if you think about where R is going to be, R is going to end up being down here in this quadrant. Well, down in that quadrant, my X value is negative, and my Y value is negative. So my new R value is going to be at -2, -3. And you can do this any single time. You could draw the picture in there if you want. But my suggestion would just be, remember, if you're talking about a 90 or a 270 degree rotation, the numbers are going to flip-flop, and then just ask yourself, do I expect the numbers to be positive for X or negative for X, positive for Y or negative for Y? If you were to go in the clockwise direction, still 90 degrees, the picture just would have ended up in this quadrant over here. If you go 180 degrees, you'd end up somewhere down there. If you end up with 180 degrees, the X and the Y values will stay the same. You'll keep the same numbers, and then just evaluate whether you want them to be positive or negative. Now I'll focus on the idea of translation. And in a translation, all this is a slide. This is what we're going to call same orientation. Nothing is going to change about this thing except we're going to be sliding it across the paper, up, down, left, right. And they're going to give us the translation here. In this case, they're saying take every single point, and we'll pick S to start, and take your X value -5. Well, don't forget, X is this axis here. Okay, your X axis. So basically we're saying take your X value and slide it 5 spots back. And then since it's Y -3, it says 5 spots back and 3 spots down. And there's my new S value. I do the same thing with Q. 5 spots back, 3 spots down. I do the same thing with K. I do the same thing with J. And I end up with a quadrilateral that is identical, congruent. The only difference is the location. In this particular case, it got shifted because it's a -5, 5 spots left. Because it's a -3, 3 spots down. Whatever this is, that tells you what your left and your right shift is going to be. If it's negative, you're shifting left. If it's positive, you're shifting right. The Y tells you whether you're shifting up or you're shifting down. You could do the same thing with this bottom one. If you took the Y value and slid 4 spots back, in this case 6 spots down, you end up with a point that's right here. If you do that with all of them, you'll end up with a picture that, like we said before, is congruent, but just shifted down the page. It has same orientation because it looks the exact same. Looking at the same situation here. In this case, the translation, we're still going back 1 spot and we're going up 5. What might happen is if I go back 1 and up 5, there's a chance that in this case, these things look like they're almost exactly on top of each other. And that's perfectly fine. They might actually end up overlapping, and there's nothing wrong with that whatsoever. And there's my new translation. What if they just give me the ordered pairs here? In this case, they're saying the x value stays the same and the y value goes up by 2. I could graph these points if I wanted to. Or I could just simply do this. For my new b value, it says x stays the same, and it says add 2 to my y. For my j, x stays the same, add 2 to my y. X stays the same, add 2 to my y. So now I end up at negative 3, negative 2. I end up at negative 2, 0. I end up at negative 2, negative 2. And this is my new, based on this order of pairs, these order pairs here, that would be my translated figure. I could go ahead and graph these if I wanted to, and see what the original figure looked like, but in this case, just ask me for the translation. Well, now we're going to talk about glide reflection, and I would strongly suggest checking out the PowerPoint for this one to sort of see what a glide reflection is. But essentially, it's going to take a reflection and a translation and marry them together. So if I draw my original picture, I draw my h at negative 5, 2. I draw my L at negative 1, 3. And I draw my K at negative 3, negative 1. This is going to be my original triangle. My H, my L, and my K. Well, now it's time to reflect across the y-axis. So go ahead and I do that. I get a new K value, a new H value, and the new L value. And this picture, I'm going to dash it instead of making it solid lines because this is not really part of my answer. It's just an intermediate step to get to my answer. Because I still have to worry about doing this translation. So I have to take all these points. And because these are going to overlap, it's going to look a little bit tricky, but just sort of follow my logic. I'm going to use x's where my new points are instead of just dots. So I'm going to take all my points. Let's start with point L. I'm going to go 1, 2, 3, 4 spots back, and I'm going to come 2 spots up. So my new L value is right there. I'm going to do the same thing with K. 1, 2, 3, 4 spots, 2 spots up. Do the same thing with H. 1, 2, 3, 4, 2 spots up. And this picture here is going to be what we call a glide reflection. It was reflected across the y-axis and then it was shifted back. Check out the PowerPoint on this, and what you'll recognize is the order that you do these two things is inconsequential. It doesn't matter whatsoever. The last thing we're going to look at, and this might be the most difficult just because it's symbols and just because we're talking about ways to represent it, is the idea of symmetry. We're going to use the letter D for symmetry, and we're going to use the letter Z. If you have symmetry D sub 4, what this simply means is there are 4 lines of reflectional symmetry. If you're talking something like Z4, it means there are 4 points or angle measures of rotational symmetry. And if you look on the PowerPoint, there's a couple really good examples there. But let's just give you a couple examples by looking at the letters of the alphabet. Let's start out by looking at a capital A. If I look at the capital A, if I were to twist this thing 90 degrees, it's going to look like that. If I twist it 180, it looks like that. If I twist it 270, it looks like that. None of these look the same until I end up back 360 degrees. So this only has one point of rotation, and that one point of rotation is 360 degrees. But now I'm going to come down and I'm going to look and say, okay, what are my lines of symmetry? Well, in this case, I have one line of symmetry. If I were to fold this across that line, it's going to look the same on the top and the bottom, so left and the right. So this is what we would refer to as, because we try and go to our lines of symmetry if at all possible, we're going to refer to this as D1 because it has one line of symmetry. The letter B falls into the same exact category. If I rotate this thing and I put it on its side, or if I go backwards with it by 180, or if I go another 90 degrees, none of them are going to look the same until it ends up back where it started from. But it does have one line of reflection, so we're going to classify this D1. Check out the letter I and the letter H. Well, we know that if I go 90 degrees, my eye's going to look like that. But if I go 180, these two pictures are identical. You'd never know the difference if I did that. If I rotated another 90, you'd recognize the problem. And if I rotated 360, so now this is what we call two sets of rotational. Because I can go 180 degrees, or I can go 360 degrees. The eye also has two lines of symmetry. When push comes to shove, whether we use the letter D or we use the letter Z, because there are lines of symmetry, we're going to call this D2. Focused on the idea that there are two lines of reflection. Same thing with H. There are two lines of reflection, so this would also be D2. Other letters that will fall into this would be the capital letter S and the capital letter Z. But what if I'm looking for 4 rotations and 4 reflections? Well, that's where you get a letter like X. If you rotate X 90 degrees, 270, or 360, they all look the same. There are 1, 2, 3, 4. There's also 1, 2, right on the line itself, 3, 4. So this would be classified as D sub 4. Other letters that fall into that category would be the letter O. And now to wrap things up, the things we looked at tonight are reflection. And keep in mind we're going to talk about the X and the Y axes here. So if we're talking about reflecting across the Y axis, we're just going to take a picture that's on this side and reflect it across. It's going to have reverse orientation. If we're talking about rotation, think of an idea of a Ferris wheel or a merry-go-round. Think about the idea if we're going clockwise or counterclockwise. And also focus on the fact that a 360 degree turn means I end up right back where I started. So we're going to talk mainly about 90, 180, and 270, whether it be clockwise or counterclockwise. But remember, anytime you end up with a number higher than 360, for example, maybe it's a 540 degree rotation, well, 360 puts me back at my starting location. So just subtract 360 off as many times as you need to. And then a rotation of 540 degrees and a rotation of 180 degrees are the exact same thing. We talk about translation, and this is basically just a slide. All you're going to do is figure out how do my X values change? Do they shift left or right? And my Y values, do they shift up or down? The glide reflection takes the reflection idea and the translation idea and puts them together by first doing a reflection and then a translation, or vice versa. You're going to end up with an intermediate figure in between but that will not be part of your answer. So if we take a picture like, say this, and we do a reflection across the y, well, this is just an intermediate step. And then when I go ahead and do my shift, let's say the shift ends up being a few spots to the left and a few spots down, well, then my new picture might end up being here. So there was the reflection, and then there was the translation with this translation vector. When we talk about symmetry, we'll focus on the letters D and Z. Keep in mind that a letter, a number, a figure does not have to have any lines of symmetry, but it will always have at least one rotation, and that's 360 degrees. So if you end up with an idea like the letter J, which if you spin it around, the only time it'll look like itself is if you go all the way around 360 degrees, the letter J would be what we call Z1. Z2 would be any letter or figure that had 2 points of rotation, 180 and 360. And Z4 would be any that has a rotation of 90, 180, 270, and 360, all of which gave us the exact same picture. When we talk about D, we're going to focus mainly on D2 and D4. D2 is any letter or any figure that has 2 lines of reflection, and we talked about the letter H being a possibility because it has a horizontal and it has a vertical. If you talk about D sub 4, it's going to be any letter or figure that if you take it and you draw it out, for example, the letter X, there is 1, 2, 3, 4 lines of symmetry. We're going to focus mainly on D2, D4, Z1, Z2, and Z4. But this number down here, the 1, the 2, 4, that could be any number based on the number of reflections or the number of rotations.